Okay, class, hello. We're going to go over the test review for practice 3. So, this test review, you can print this from your module related to the test 3 material, course material over chapter 5 and 6. And the first couple pages, if you read through that, it tells you things that you should be able to go over and review. So it'd be helpful to look at that. And just look through that and read through that. But if I start working out your problems on your practice tests here, okay, it covers chapter 5, sections 1, 2, and 3, and chapter 6 also, 1, 2, and 3. So if I take a look at this first problem, it says, determine whether the distribution represents a probability distribution. Justify using complete sentences, discussing the two requirements that either they are satisfied or they're not satisfied. So you want to report on each of the activities, each of the requirements. So the two requirements are that, first of all, when you add up all these probabilities, they have to equal 1. And then the other requirement is that each individual probability has to meet that requirement, that it's basically a value that's between 0 and 1 inclusive. And so you want to talk about that. Okay, so when I have here show your work required as demonstrated during class, this is showing the work about the summation, see what the value of the summation is. So you want to start with this summation symbol, sigma, and P stands for probability of X. And you're adding up all of these probabilities here. So I have probability of 1 plus probability of 0 plus probability of 5 plus probability of 8. So that's all of these. And then when I add their value, this one is represented by 1/10. This one's represented by 2/10. This one's represented by 3/10. This one's represented by 4/10. And then when I add all those up on the calculator, 0.1 plus 0.2 plus 0.3 plus 0.4. It looks like that gives you a value of 1. Okay, well, that's a good thing. Okay, so there's two requirements that are met, and it looks like the first one is met. So on the justification, you want to speak to that. You want to say something like, the sum of the probabilities of all the events in the sample space equal 1 as shown in the scratch work above. Okay, so I'm going to write that down. Okay. And then on your test, you don't know on your test if you're going to get a problem where they do equal 1 or they don't equal 1. If you get a problem on the test and then they don't equal 1, then you need to justify that and say that the sum of the probabilities of the events in the sample space do not equal 1, and you can say that's not a good thing. It's supposed to equal 1. And you say, oh, we have an issue here. It doesn't equal 1. So you just voice that. Okay. Now there's two requirements that need to be met. So you do need to talk about the other one. And the other one is that each of the probabilities should be between 0 and 1. Okay. So if you look at this one, if you think about money, this is like a 0.1, that's like a dime, right? 10 cents, 20 cents, 30 cents, 40 cents. So it looks like all of these meet the requirement that the probabilities are between 0 and 1 inclusive, okay? So one way you can show that is for each one individually. um, you can say here, um, so also uh, each event's probability satisfies this inequality, that each probability is between 0 and 1 inclusive. So you see the underscore, okay? And then you would just show that, and you could just show that as shown below. And then you would just show that. So the first one is P of 1, which is, like we said, a dime, like 10 cents. And that is a value between 0 and 1, okay? Also, the second one, probability of 2, that's about 20 cents, right? 0. That's between 0 and 1. The other one, probability of 3, that's, oh, excuse me. I need to go back and fix this. It's probably a 1. This one's actually probably of 0. See, probably of 1, probably of 0. And then this one is probably a 5. Yeah, so they don't always go in order. So this one's 1, then it jumps to 0, and then it jumps to 5 and 8. So probably a 1, probably a 0, probably a 5 is like 30 cents. And then the last one is probably of 8, which is like 40 cents. Okay. But you're showing that each one is a value between 0 and 1. Okay. Or if you wanted to, what you also could do, you could draw, I think I also did this in class. I drew a number line, and I put here like, here 0, and then over here 1 with brackets. And then I could put these in, like one of them is 10 cents and then 20 cents. So this one's 10 cents, this one's 20 cents. This one would be like 30 cents. Maybe extend this out a little bit more. And then this one I could put is 40 cents. Okay. And then I could put one way over here. Okay. So here you can see that each probability is between 0 and 1. See, here's 0 and 1. And you could say that each event's probability satisfies this, and you would draw a picture and you would show that these are all between 0 and 1 inclusive. That's also saying this, right? So also each event's probably satisfies this, as shown below, using either inequalities or a graph. Yeah, so you could either do this. I think I did both of these in class. I did this, or I also did a graph, and that shows that, right? That justifies that. So that means that yes or no determination, that means that yes, this distribution represents a probability distribution. So in order for it to be a probability distribution, both requirements need to be met. And I think usually what kind of mistakes happen on the test, I think, is usually students don't speak to both of the requirements. So you've got to address both of them and show and confirm that both of them, let me know if each one works or not. But you've got to speak to both of them. You just cannot voice and not address both issues. So you need to inspect both requirements, okay? Okay, now on the next one, it says, state whether the variable is discrete or continuous. Justify your response, including the definition. So here it says the weight of an automobile, okay? So this variable happens to be continuous. And the reason why it's because the data can be measured using an instrument rather than counted using 1, 2, 3, and so on and so on. So the data can be measured using an instrument. So like in this case, you would need some kind of a large weight scale, right? To weigh the automobile, the car would have to be placed onto a large weight scale to weigh it. So you need an instrument to find the weight of an automobile rather than counted, which means like enumerated. Enumerated. So rather than counted, enumerated using your counting numbers. 1, 2, 3, and so on and so on. Okay. So again, on the test, you want to know the write-up for discrete also. Like you want to know the write-up for discrete and continuous, because on the test you don't know what you're going to get. You don't know if you're going to get something that's continuous or something that's discrete. So you also need to know the write-up for discrete as it could appear on your tests also. So something like that. Usually that one has the keyword, the number. So usually you have the keyword. Right, we talked about that in class, the number, right? The number that usually comes in. When we talked about that, if you go back to your notes. Let's double check something. Yeah, I'll double check on the keyword, but yeah, we said the keyword is like the number of, right? So that one can be counted, okay? All right, okay, so then let's look at the next page. Okay, so it says the counting highway department recorded the following probabilities for the number of accidents per day on a certain freeway for 1 month. The number of accidents per day and their corresponding probabilities are shown. Okay. So they want you to find the mean, the standard deviation, and the variance for the probability distribution using the calculator, and then round according to the rounding rule for probability distribution. Okay, so what we would do on our calculator is we would enter our data, right? Enter your data. And I would put the X data in L1 column, enter the P of X, the probabilities in L2. So I would go ahead and do that on your calculator. So we can do that right now. So you want to go to Stat, and that Edit, one Edit, and then Enter. And then just go up to the top and clear. And then Enter, right? And then tab over here, go up to the top, clear, enter. And then just start typing in your data, 0, 1, 2, 3, 4, and then go to the second column, 0.4, 0.1, 0.1, 0.1, 0.3. Okay. And then you want to press Stat and calculate, or calc, and one variable stats, enter. And then you have your lists and your frequency lists, and then here you have calculate. Yeah, so your list is your L1, right? So that's your X data, and that would be what, second and the number 1. And then your frequency list would be L2, which is your probabilities. So it'd be second and the number 2, because that brings up L2. Second and the number 2, and then calculate, enter. Okay. And then do you see how it shows X bar? But you're not going to write X bar for the mean. Remember, you're gonna write mu. Okay, so you're gonna look at X bar, but you're gonna write mu. Okay, for your mean, and then it gives you 1.8. And the thing about the rounding, the rule for rounding says that here your data is presented in X row as counting numbers. So that means you're going to round answers to 1 decimal place beyond to the 10th place. Okay, so your data is entered as X. These are all counting numbers. So you're going to round 1 decimal place beyond that, which is 10th place. Okay, so but this is already 10th place. So we don't have to round. If it were longer, then we would round it off to the 10th place, but this is actually done already. And then your standard deviation is your sigma x, which is this long number here. And that one you will round that off to the nearest tenths. And the tenths is this 7th place. And then you look at the number to the right. Is that 5 or more? Nope. So it stays 1.7. And yeah, so I would always write down your exact value and then round that off. And I usually ask for that on the actual test template, like write actual exact value, write the exact value so I can see what it was beforehand, okay? So I can check that you inputted the numbers correctly. So I check that we get the exact value here. Then we round to tens. And remember for the variance, remember no calculator, no one's calculator provides the variance. So remember what you have to do is we have to actually square the standard deviation. Okay, and then you need a symbol for that, which would be like this. That would be your symbol, sigma squared. And then you don't use the round off because then you have round off error. Always go back to the exact. And then square that. And you use this key right on your calculator to square it. Okay, so you can just type that in here and then this will disappear. Sometimes there's a need, like if you have a table, a list of columns, sometimes you have to do second quit, right? But sometimes you can just type, like I'm going to type 1.72 and it just, the other just disappears. And then you square that. And this is a long number. And we don't have any units here. Sometimes if you have units like cents or inches, you put your units, but this one didn't have any units on it. Okay, so I don't have to put any units on that one. And then round to nearest tenths. Look at the right, is that 5 or more? Yep, it's a 5, so add 1. So it looks like that's, when you add that, that's 10, then you have to add 1 to that. So it looks like this is 3.0. And I would write the 0. It wants you to round to the tens, right? So even though it's a 0, I would write it because that's tens place there. So I wouldn't leave it vacant because they want you to record tens 1 decimal place beyond the data. Okay, next. In a survey, 62% of Americans said they own an answering machine. So that's your probability. And you want to move your decimal 2 places to the left, right? Or you can do 62 divided by 100 also. If you do 62 divided by 100, that also gives you 0.62. Sometimes people forget did she say move to left or to right? So that will help. If 21 Americans are selected at random, so that's a keyword, right? The selected at random, 21, that's your N. Find the probability using the calculator that exactly 13. Okay, so that's your keyword, exactly 13. So you want to have this this sheet out, and where you're looking at this vocabulary. I'm just noticing you're also going to use this sheet for quiz 3, and I think I've changed this one before. This remember we're supposed to fix these here. These are supposed to be little semicolons here. I have too many equals here. So if you haven't done that on your paper, since I have my white out, if you haven't fixed your paper yet, this is going to help for quiz 3, but these should have semicolons here. I have way too many equal signs here. This is the null hypothesis and the alternative hypothesis. We're going to use this when we do chapter 8. I think it's 8.1 for quiz 3. I thought I fixed it. I think I have a recording of me fixing it. But I have different pages. I haven't fixed it on all my pages, but there you go. Okay, so for us, the keyword is exactly, which is up here. This is probability x is equal to the given number. For us, it's going to be 13. And this is going to equal binomial PDF, which is for exactly in px. And then you're going to substitute in px in there. Okay, so I'm going to use that. So that's where that's coming from. So I have x is equal to 13. This is equal to, and let me move this 62 over 100 over here. Move that here. Let me take this off. Okay, so I have binomial PDF and px. And then you're going to substitute. N is 21, p is 0.62, and then x, remember, was exactly 13, remember? And then to get to that on your calculator, you do need to do a second vars, and you need to scroll down to binom. Let's see, the long way, I forgot the shortcut. The long way is to scroll all the way down to A, binom PDF, and that's in A. But the shortcut, let's see. So I can remember the shortcut. See how A is on top of math? And see how it's green? So that would mean you want to do alpha and then math, because that will give you your A. So either you scroll down the long way, which takes a while, or you do second vars and then you do alpha math, and that would take you there. And then just double check, see, binomial PDF, just double check that's what you want. And then and let me see. Okay, so then your trials would be 21 of them. And then your probability is 0.62. Then your x value is exactly 13. Okay, so I could put that here for you. So you don't have to put this on your test, but you fill in the blanks. You do need to fill this in and fill this in, but you don't need this part, just in case, to help people. And then hit enter. And then these are going to round to the nearest thousands, tens, hundreds, thousands. And then look at the number to the right. Is that 5 or more? Yep, it's a 9. So add 1 to that. So 0.177. Okay, and I also put it here in case it, when I If I scan that again, it might chop off, so put that there. Okay. Okay, let's go to the next one. Okay, so for the number of heads when 5 coins are tossed, find the mean and the variance and the standard deviation for the variable that has the binomial distribution using the formula. Okay, so binomial distribution. Yeah, so binomial being 2, right? Okay, so you're tossing 5 coins. So your in is going to be 5 tosses. And on your probability, you know, the idea of probability is the number of, you know, like successes over the total outcomes. Okay. So on your total outcomes, you either have heads or tails. So that's where your, you know, your binomial two situations can occur, right? And you're interested in the heads, right? So that's where the 1/2 comes in. A point is either heads or a tail, so the heads would be 1, and then there's 2 outcomes. Okay, and that also equals to 0.5. Okay, your probability. And I have a note here that because you have to find Q, you have to remember Q is the definition 1 minus P. Sometimes people forget that. So then they don't know how to calculate Q because they forgot the formula, but it's 1 minus P. In this case, it's 1 minus 1/2. Okay, so you either make this a common denominator, and this is like 2 over 2 minus 1/2, which would give you 1/2. Okay, which is also 0.5. Okay, and I have a note here. Let me put over here a note to self that if P is not a terminating decimal, then work with the reduced fraction. Instead of a as decimal. And that would be to avoid round off error. Yeah, so like if you for some reason let's just say your probability was reduced to 1/3. 1/3 is not terminating. Like 1/2 is terminating, right? 1 divided by 2 that terminates, but 1 divided by 3 that doesn't terminate. That's repeating. So when you do your P, you can't just say, "Oh, I'm going to make that 0.3 or 0.33." You can't just decide what to round off to. And then if you round that off, then when you do 1 minus P, you're going to have more round off error because the 0.3 or 0.33 was rounded off. So you shouldn't do that. If you ever get a fraction that doesn't terminate and you cannot make it into a decimal, you've got to work with the fraction like 1 minus 1/3. So you'd have to do 3 over 3 minus 1/3. because you want to avoid round off error. So that's what that's talking about, okay? Yeah, so again, the 1/2 is the coin has two sides, right? 1 and 2. And then the heads, right? One head, so 6 for success, okay? Okay, so then your mean, this is where your formulas come in. So your mean, remember, you're going to use mu like we did earlier, but you have the formula n times p. So here n was 5 and p was 1/2. Okay, and so when you multiply that, 5 times 1 is 5, and this is imagining 1 times 2 is 2. That's 5/2. And 5/2 is 5 divided by 2 is 2.5 as a decimal. Okay. Okay. Or if you want it to work, 5 times 0.5, because it does terminate. So of course, if it doesn't terminate, then you shouldn't work with like 0.3, you have round off error. But if it terminates, 5 times 0.5, you see that does give you 2.5. Okay. And then the variance is sigma squared here. And remember that formula was n times p times q. So n was 5 and p, if you want to use 0.5, okay? And then q was also here 0.5, remember? And so you have 5 times 0.5 times 0.5, which is 1.25. So the thing is, you have to just remember your formulas in PQ, right, for the variance squared. And then variance was the square root of that variance, okay, sigma squared, which is n times p times q. So n is 5 times p is 0.5 times q is 0.5. Again, if it didn't terminate, then you'd have to work with your fractions, right? This one terminates. So we already know 5 times 0.5 times this is 1.25. So this is the square root of 1.25. So the square root is the second button and the x squared button, because that's got the radical. So second square root 1.25, which is, and you saw that sometimes second square root, sometimes sometimes you see how long that is. Sometimes you see me do this, push this out like that, right? Okay. Okay, let's see. Let's see. Okay. I have a note here. Let's see. Okay, I have a note here on the rounding. Okay, this one says round to the nearest tenths. So I'm going to round this in a, but I was looking at the previous one. It looks like I rounded the previous one. So this one nearest tenths, is this 5 or more? No. So that's 1.1. Okay. And then I also have or. Let's see. It looks like I used fraction. So I did 5 over 1 times 1/2 times 1/2. Because remember, these are 1/2 also, right? In case they don't terminate and you have to work with fractions, remember you just have to multiply straight across. So 5 times 1 times 1 is 5. 1 times 2 is 4. That's a square root of 5/4. And it looks like I put that in parentheses here. So if I were to do that, second square root and then parentheses 5 divided by 4, like that. And we get the same thing, okay? So that's in case you get something that doesn't terminate and you've got to work with your fractions to kind of give you a little review of your fractions there. Okay, and then this one, it looks like on this one I have a note here on the paper to round to the nearest tens. So if I round this nearest tens and look at the numbers, is 5 or more? Yes, so round that up. So 2 plus 1 is 1.3. Okay. And again, if you had to work with your fractions, this would be, or this would be 5 over 1 times 1/2 times 1/2. So you multiply straight across. 5 times 1 is 5. 2 times 2, right, times 1 is 4. That'd be 5/4. And then 5 divided by 4 is 1.25. Yeah, so that gets that back to that. Then you round that to nearest tens, okay? And then just sometimes if people sometimes get stuck and there's this situation, you know, you could grab some points, you know, if you get the end result wrong, because you get stuck here, you could still gain some points by putting the symbol in the formula. The symbol in the formula counts some rubric points. That way you don't, if you just leave it totally blank, then you're losing all these points, right? So you should put something down. If sometimes people go blank up here on this top part, they're not sure what they're doing is right, but you should try it, right? Put something down and then at least also put your formulas down, because at least you're getting some points for knowing the symbol and the formula instead of leaving it all blank. Okay, next, construct a probability distribution for the birthday cake sales data. The probabilities that a bakery has a demand for 2, 3, 5, 7 birthday cakes on any given day, and those are their probabilities: 3,500, 4,100, 1,500, and 900. Okay, so here number of, this is birthday cake sold. And that's X. And then this one is the probability. These are the probabilities. So we had 2 that was reflective of 3,500. We had 3 that was reflective, respectively, it said respectively, so in that order, 4,100. 5, that's 1,500. And 7, which is 900. Okay, so there's an extra cell here that we just don't need. What is the probability that the bakery will make 5 or 7 birthday cake sales during any given day? Complete the probability, include work for full credit. Okay, so probably a 5 or 7. 5 or 7. Okay, so here we're using the addition rule, number 1, for mutually exclusive events. So remember this then, okay, mutually exclusive events. So events that cannot occur at the same time. Okay, so we're doing this. Probability of A or B is equal to probability of A plus probability of B. Okay, so here we're going to have probability of 5 plus probability of 7. So probability of 5 is 0.15 plus probability of 7 is 0.09. Oops, I don't need parentheses on that. And then on the calculator, when you add, see, here's probably a 5 and here's probably a 7. So when I add that 0.15 plus 0.09, that's 0.24. Okay, job bids. A landscape contractor bids on jobs where the contractor can make $3,625 dollars in profit. The probabilities are of getting 1, 2, 3, or 4 jobs per month are shown. So here's your number of jobs and here's your probability. Find the expected number of jobs per month using the calculator. Round according to the rounding rule for probability distribution. So these are county numbers. So when you round 1 decimal beyond counting, that's going to be tens place. So that means this is saying that we're going to round to the tens place. And that's because these x's, that's because the x's are county numbers. Include the symbol for the expected number of jobs per month in your work for full credit. Okay, so this is mu, which is equal to E of x. Remember we talked about that being the expectation, and that's basically the mean. It's basically the mean. So we're going to put, just like we did earlier in the other problem, put these L1 and L2. So you're going to enter your data. Okay, and we're going to look up the x bar, but we don't write it as x bar, we write it as mu. And then since they have, because we didn't put ex last time in the other problem, we just put mu because they didn't have expected in there, because now we have expected, we need this e of x. Okay, So let's go to stat, edit, and go up here and clear. Okay, so let's see. So 1, 2, 3, 4, and then 0.2, 0.2, 0.3, 0.3. Okay, and then go to stat and then calculate, right? One variable stats. Oh, and this, let's see, lists and frequency lists. Yeah, so list is L1, that's your X, and list is L2, that's your probabilities, okay? So, and we have that because we did this in the previous problem, we kind of already have that set. And it looks like X bar is 2.7. Yeah, and that's already rounded to nearest 10. So you actually don't have to do any more rounding because that's already, and you don't have to put any labeling because these are jaws, but they're not units. Let's see. Yeah, we're actually fine here. The units are coming up on the next part when we do the profit, and that profit has a $sign. So next, find the contractor's expected profit per month, include the formula and the units, see, in your work. So here you're going to take your E of X times your profit. But be careful here. I would advise you to use the exact E of X, not the rounded E of X. Now for us, the E of X was just 2.7. We didn't have to round it. But if it had been longer and you would have had to round, when you do this part, you should use you don't want to have round off error. So this, you should use the exact value times the profit and then round that off to the nearest. And this is money. This is money. You should round to the nearest cent, right? If it's money, round to the nearest cent. So here, this doesn't really affect us because 2.7 had already terminated. Okay, so again, this is fine. If I type this in, that's fine here. 2.7 times 3625. And this is money. So even though it says 0.5, it's like 50 cents. If it were longer, then I would round off to the nearest, like 52 cents, 53 cents, like nearest cent, which is hundredths place. Okay. So round to nearest cent, which is hundredths if necessary. So this one chopped off on its own. I just have to add a 0. Okay, let's see. 53% of all persons in the United States population have at least some college education. Choose 10 persons at random. Okay, so that's 10 persons at random. So that's your N, right? And then the 53%, that's your probability, right? 53%. So that's 53 over 100, which should be 0.53, right? And then the keyword is have at least, let's see, some education. Okay, here it comes. Find the probability that fewer than six have some college education. Okay, so where's my vocabulary? Fewer than six. So you have to look for, here we go. See, fewer than. So you got to look at all these words, and here it is. So see this right here? This is what we're going to use. Probably X is less than, and the given number was fewer than six. So we're going to do this. And it's a binomial CDF in PX minus one. So this is going to be 6 minus 1. Okay. So this is what we need to write down. Okay. So probability X is less than the given number, and the given number was 6. And this is binomial CDF in P X minus 1. Okay. So this is binomial CDF. N is 10. P is 0.53. X minus 1 is going to be 6 minus 1, which is 5. Okay. And then this one is going to be CDF starts from 0. So this is going to be, you're finding P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5. That's not that many. If it were like all the way to like 20, you could do P of 0 plus P of 1 plus, and then do dot, 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 plus, and then do like P of 19 plus P of 20. This wasn't that many. This was 5. And that's what you're finding. So that means that this X is what you're finding. X is 0, 1, because these are P of X's, right? P of X's for probabilities. So your X's are 0, 1, 2, 3, 4, 5 on that. Okay. And I'm wondering, did we do another problem like that? Yeah, I think, let me go back to this other one. I think I left off one little step on this one. Remember we did this one? It was an exact 13, right? Exactly 13. This was exactly 13. So this one would have been here, if I can squeeze this in here. This one would have just been P of 13. This is exactly 13. So this is just P of 13, which is this value. So it's like saying like P of 2 is this value, right? That's kind of, this is like P of 13 is this value. It's kind of what's happening there. Okay, so that one, should have put that in here. And that was for 4 on that one. Okay, now on 8, this is good. And then this is a second vars. Second vars. And you want the CDF. So let's see. If I just go all the way down, see that on B? See, that's B. If you scroll all the way down, see that's B, CDF. If you do the shortcut for B, that's on the apps. See that? Can you see that there? That's a B right there. And it's on the apps. So the shortcut would be alpha and then the apps, because right on top of the apps is you have a B. So you either scroll all the way down and make sure it says CDF. Okay. Let me put here trials P X value. Okay. Or you do second vars and then alpha apps, and see, and you just double check that. See, CDF. Okay, so then your trials are 10, and your P probability is 0.53. And then your X values, remember, you have to don't put 6, it's 6 minus 1. Sometimes the formulas require you to subtract. See, depending on your vocabulary, like this one and this one. So if you have these vocabulary words, you must do the subtraction on that X, see? So it's not 6, it's 6 minus 1, which is X values. You're going to put 5 here. So you have 10, 0.53, and then 5. And we're going to round to the thousands, tens, hundreds, thousands, and then look at the neighbor to the right. Is that 5 or more? No. Okay. A missile guidance system has 5 fail-safe components. Okay, so that's your N. The probability of each failing is 5%. So that's 5%, which is 5 divided by 100, which is 0.05, right? You move it 2 places to the left. Find the probability that more than two will fail. Okay. More than 2. Okay, so I go back to my vocabulary. More than 2. Right here, more than. See this more than? And this is a complement. See this? And see this? Probably X is greater than the given number. And this is 2, more than 2. So that given number is 2. 1 minus binomial NPX. Okay, I'm going to write that down. So probability X is greater than the given number, which is more than 2. That's a complement. 1 minus binomial CDF NPX. So no subtraction on this one. So 1 minus binomial CDF N, which is 5, P, which is 0.05, and then X, which is 2. Okay. Okay, I have an extra line in here. Let me see if I can squeeze this in here. This is okay. This is accurate. I do have this. 1 minus, and this is probability X is less than or equal to 2. So that is true. If it's greater than 2, you're doing 1 minus probability that X is less than or equal to 2. So that is true. That's like its complement, right? That's the complement of this. The complement of greater than 2 is less than or equal to 2. So that is true. 1 minus that. Okay. All right. And then let's see. So then what does this look like? Before I use my calculator, what does this look like? 1 takeaway. Remember, CDF starts from 0. So you're taking away P of 0, taking away P of 1, taking away P of 2. And see, you stop there, see? CDF starts from 0 to 2. So you're taking those out. And then what are you left with? What are you left with? So you're left with P of 3 plus P of 4 plus P of 5. Yeah. So you know when you add them all up, P of 0 plus P of 1 plus P of 2 plus 3 of 3 plus P of 4 plus P of 5 equals 1. So you're taking away P of 0, P of 1, P of 2, and you're left with P3, P4, and P5. So that's true, okay? Okay, now we can use a calculator. Oh, and also that's what this is. You need, this helps you with X. You need X. This helps you with X. What are you summing? What are you summing? So you're summing P of 3 and 4 and 5, okay? See, because it's greater than 2. So greater than 2, and then it stops at 5. Okay, so 3, 4, 5. Okay, and we're doing a second vars, and it's a binomial CDF. So do second vars, and then oh, be careful, be careful. We got to do. You have to be careful. You have to do 1 minus 1 minus. So let's go back. And also CDF, we saw from the previous problem, CDF is the alpha B. So I'm going to write that down. Alpha apps, because you want B. You want the CDF, okay? So now you're going to do 1, very important. I think that's why people miss this, because they forget to do the 1. They have it here, but they forget. They just go straight to the calculator. You have to do 1 minus, and then second vars, and then alpha apps, and then the trials would be so the trials would be 5. The probability is 0.05. And then the X value is 2. And then you round to 3 decimal places. I said 3, tens, hundreds now, 3 decimal places. Then look at the number to the right. Is that 5 or more? Yep. No, it's not. No, it's not. So it's 0, 0, 1. Yeah, so in chapter 5, we round to thousands. In chapter 6, areas underneath the curve. When we do chapter 6, areas underneath the curve, that's when we have 4 decimal places for that, okay? Okay, I hope everybody got that. Everybody get that? Okay, so let's see. Next one, 10 says, find the area under the standard normal distribution curve between z equals 1.19, so 1 in 19 hundredths, and z equals 1 in 87 hundredths using the graphing calculator. Okay, let's see. They want you to draw a normal distribution curve, shade the area, taking care to label the mean and the standard deviation, and the z-scores on your curve. It's demonstrated in class. Okay. So for this one, mu is 0, sigma, way over here, sigma is 1, and z is between 1.19 to 1.87. So you get your rulers out, and let me just put this about somewhere on this side. Let's see. So z is 1.19 and 1.87. Okay, and then you're trying to find this area here. Okay, so then when we use our calculator, these are z's, so z's are trapped. These just one that's sandwiched, so it's trapped. And these are on this side. 1 something is beyond 0, so you're on this side, right? So this is trapped between 1.19 and 1.87. Okay. And then when we use the let me do this two ways, a table and then the calculator. So let me do the table first. So when I do the table, you're going to do the larger area, 1.87, minus the smaller area, 1.19. So the larger area minus the smaller area. So on your table, the larger area is 1.8, the first two digits, and then 0.07, and then 1.1, the first two digits, and then 0.09, right? Okay. And when you look these up on your table, 1.8, 1.8, and then 7. Okay, see that number there? Can you see that number? Looks like 9693. Right. See that? 9693. Okay, and then the other one is 1.1 and then 0.9. 1.1 and then 0.9. Okay, see that number right there? 1.109, 0.8830, 0.8830. So then when you're subtracting, you're going to subtract 0.9693 minus 0.8830. 0.9693, take away 0.8830. 0.8. 0.63. Okay, now when you use the TI-84, we have that it's sandwich 1.19, 1.87. It's sandwich, but then we're not using the tables. So then you don't need to show larger minus smaller because we're not using the tables. But you need the calculator command, which would be the 2 normal CDF, lower bound, upper bound, mu, and sigma. And then your lower bound in your picture, this right here is your lower bound because you regress from left to right. This is your upper bound. This is your lower bound, this is your upper bound, lower bound, upper bound. So 1.19 to 1.87. Mu is 0, see, and sigma is 1. And that's a second vars. Second vars, and that's number 2. So you don't need any shortcuts for this one. And then the lower bound is 1.19. Upper bound is 1.87, 0 and 1. And when you round to 4 decimal places, 1, 2, 3, 4, because the area underneath the curve is 4 decimal places. Is that 5 or more? Yes, that's an 8. 0.863. And they are identical. Yeah, so I would put both of these down on your notes, and then I think on the test I do ask for a variety. I don't know. I think sometimes I ask for the TI-84 command, and then sometimes I ask for the table. But I do need at some point to demonstrate both of them at some point. So I'll have to look at the tests, and I might have to tweak the template a little bit that I have up. I'll have to take a look at that after I do the review before I post the test to make sure everything is up to date on that. But I would put both of these on your paper, and then you're just not sure which one I'm going to ask for, okay? Because I taught both of them in class, so you should be able to demonstrate both of them, okay? And then I'll ask for one of them. Okay, now down here, oh, the other thing I have a note of is I have a note that be able to do any of these 3 cases. To be able to do, let me see, write this down. Any of these 3 cases could appear on the test. Yeah, so remember there was 3 cases when we first started this section 6.1. This was the sandwich in between. And then there was the easiest case, which is when you have areas, mu is 0, sigma is 1. But when you have areas, you know, like to the right of the curve. So z equals a negative number. Okay, and then, so then you have to be aware of, like, if you use the calculator, you have to be aware of negative 10,000 or the -1 E99, right? Which uses the second and the comma, right? Because the second, if you look at your second and your comma, that has the EE on there, remember that? Okay. And then if you look at your table, that's the easiest one, right? It's already to the right, so you don't have to do larger minus smaller. You just look that up on your table, because the probability is that z is less than, you know, whatever that number is, for example. And then the other case is where you have something like this on this side. So z is a positive number. And then on this side, when you use the calculator, lower bound, upper bound, here you have 10,000, or you have 1 e to the 99. And if you're using the table, you have the probability is equal to, let's see, where do I write that? I'm not sure where to write it. Remember, it has to be 1 minus the probability that z is less than. So if you use a table, you have to do the whole area of the curve is 1, take away probably less than. Remember, we had those 3 cases. So yeah, so just because this one's on your review doesn't mean that that's going to be exactly on your test. You could have these variations of them. Okay, so just be aware of them. Okay, and then you don't know if I'm going to ask for the table or the calculator, right? So you have to be aware of those. Okay. Okay. Okay, the bottom says that find the indicated z-value, the z-score to the hundredths place, because these are to the hundredths, when using the standard normal probabilities table that corresponds to the given area in the figure, not drawn to scale. Okay, so I have a little note here that recall the table represents the cumulative area under the standard normal curve. That is to the left of a z-score. So here, mu is 0, sigma is 1, and we're trying to find the z-value. They're telling us that this area is 0.1443. And remember that this area, like halfway between, is 0.5. So if I take 0.5 and I add this area 1, 4, 4, 3, and I just add those up. See, that gives me this area here. And you're interested in that because then you want the area to the left of the curve when you look things up right on the table. It's to the left of the curve. And that would be this C reflective of that. So you want to, so now you have this now. So here's mu 0. And you have this. And you have all this, which I highlighted in pink. And this area is that 0.6443. So you want to look up area equals 0.6443. You want to look for that within the standard normal distribution table, and you want to identify its corresponding Z. Okay. Okay. So when you look for that area, you want to start somewhere on the positive side of Z, because see how this is, here's me, see how this on the positive side, and also on the positive side, see how it starts with 0.5, and you see you want to go to 0.6. So you want to look for 0.6443. Okay, here's some sixes. Here we go. See that right there? It's kind of like looking for a needle in a haystack, isn't it? There it is right there. So see that 0.3 and then see that 0.07? That's your Z-score. So you have 0.3. And then 0.07. Okay. So that's your Z. So that means that Z is 0.37. Yeah, because if you add the 0.3 plus the 0.07, that gives you 0.37. Okay. So here you're testing, like the whole area underneath the curve is 1, and then halfway is 0.5, and that's what that's testing. Are you aware of those measurements? And then also you're trying to find the area to the left of the Z score, right? Okay, bottle of drinking water. Americans drank an average, that's your mu, of 23.2 gallons of bottled water per capita in 2004. Okay. H2O is water. The standard deviation is 2.7. And they're the same units. Sometimes the units are not the same. You have to make them the same. And the variable is normally distributed. What is the probability that the randomly selected person drank between 17.1 and 31.8 gallons of water? Okay, and then the way I have these broken up is because there's two parts, you're gonna have to run these through and transform them and standardize them. So I have them broken up for two pieces because you're gonna have to find a Z1 using the formula X1 minus mu over sigma, but then you're also gonna have to find a Z2, which is X2 minus mu divided by sigma. So both of these here, I'm going to put 23.2 gallons and 2.7 gallons here, both of these. And then one of them, I'm going to do the smaller one, 17.1. So see, that's less than 23.2. So I'm going to just draw that here, more or less. Doesn't have to be exactly there, but somewhere on the left. X of 1 equals 17.1. And yeah, this is all gallons. Okay. And then the other one is 31.8. So that's somewhere, C23, so somewhere over here. It's X of 2 is 31.8 gallons. What's that? Okay. I think I'm also going to draw a third graph then also. I don't know where to put it. Let's see. I didn't put it on top, okay? Yeah, I'm gonna do this one, okay? that okay if I do that? And I think in class in our notes, I showed that that they're because it's between. So I think in class I did it like this between. So that's why I'm going to put that up here. But I think this idea was, I think, to help you with this, because I see what's coming up is the table down here. When I do this at the bottom, I'm going to do the tables. So I'm going to do the larger area minus the smaller area. So that I think that's kind of why I was doing this, the larger area minus the smaller area. And that gives you this piece here, kind of the idea. But the thing is, you have to transform these x's into z's. So you see here, these are stuck between 17.1, and these are x's, and 31.8. And then you're going to run it through the system, through this formula, and then we're going to get a number here, and then these are going to become z's, and get a number here. Okay, and that's that. When you do that here, then now mu is 0 and sigma is 1. Once you transform them and run them through the formula, and then here, then now you can call this z sub 1 and z sub 2. And then we have that. Got it? And then down here, I'll do both the table first, and then on this side, I'll do the calculator, right? Okay, all right. Okay, so that's where we're going with this, all right? So let's see. And we did do that in class. I just didn't, I think, separate these two like this in class. I think I did this, and then I did that. I mean, I did this, and then I did that. But this is okay too. This is to help visualize that larger area minus smaller area. Okay, so when we run it through, we have x1, which is 17.1, minus mu, which is 23.2, and you divide it by sigma, which is 2.7. And then let's see what that gives you. Okay, so parentheses are important. 17.1 minus 23.2 divided by 2.7. And this is a z-score, so we're going to round to the nearest hundreds. Is that 5 or more? Yep, it's a 9. So negative 2.26. And so now you know that here, this would be negative 2.26. Right here, negative 2.26. Okay. Okay, you transformed it. Okay, now we're gonna do the same thing and transform the other one. And x of 2 is 31.8. Mu is the same. Sigma is the same, hasn't changed. Okay, and you probably could do a second enter. If you do a second enter and then you backspace, and 17.1 changes to 31.8. Sometimes it doesn't work out if you have an extra digit, and it's just easier to type it all out again. But if it's the same amount of digits like this, 1, 2, 3 digits, and this is 1, 2, 3 digits, and it works out, and you can save time. Again, it's a z, so you're going to round to nearest hundreds. Is that 5 or more? Yes. You can add 1 to that. And like on the tests, I would leave the exact on the test. The teacher can see that. Okay. Okay. So now this is 3.19. Okay, so that's good. So we transformed it. Okay, so now on this one, I'm going to do the table first. So the table would be the larger area minus the smaller area. So probability that z is less than 3.19 minus the probability that z is less than the minus 2.26. So larger area, but now the new z minus smaller area, but with the new z. And then when I looked that up on the table, it's 3.19 minus 2.2. So remember, it's the first two digits. Oops, it's the first two digits. So 3.1, and then this is 0.09. First two digits, negative 2.2, and then 0.06. So remember, it's the first two digits that go here, and then 0. And first two digits go here, and then 0, and then 6. And then you would look those up on your chart. Right? Okay, so 3.1, 3.1. 3.1, and then 0.09. Just this last one. Let's see. 3.1, and then 0.09. See, way over here, see? And then 3.1. See that number right there? 0.9993, right? 0.9993. Can you see that? So 3.1 and then 0.09. That's it. See? It's the last one. Okay, and then the other one is a negative 2.2. So go to your negative chart. Negative 2.2. Negative 2.2 and then 0.03. Oh, I'm sorry. It was negative 2.206. 06. There we go, right? 2.2 and then 0.06, right? Right. So remember 2.26, right? So there's the 2.2 and then there's the 0.06. So it's 0.0119. 0.0119. Okay. All right. Okay. So when I subtract those, I don't have much room, but where do I put it? Let's see, when I subtract those, let's see. 0.9993 minus 0.0119. Looks like it's 0.9874. Okay. All right. Okay. So that's using the table. Now, using the calculator. Okay, using the calculator, this will be the same. These will be the same. But then you won't need this because you're not doing the table. So this part will be the same. But then we can have room to squeeze all that in there. Or is it okay if I just say that? This would be the same. This would be the same. But instead of having this, then on the calculator, you would put, so this would be the same, this would be the same, but then instead of putting this, you're going to put the two normal CDF, lower bound, upper bound, mu, and sigma. And then the lower bound is going to be, okay, here we go. So don't look at these because these are not transformed. Don't look at this. This is not transformed. You need to go to the one that's been transformed, and it's a negative 2.26, and then upper bound. This is lower bound. This is upper bound. So then it's a 3. I don't know. I just don't have enough room to. Let me see. So lower bound is negative 2.26. Upper bound is 3.19. And then 0, and then 1. And that is a second vars. Second vars number 2. Lower bound is negative. So remember your negative is down here. Negative 2.26. And then upper bound is 3.19, 0, and 1. One, 2, 3, 4. Is that 5 or more? Yes, it is. So that's 0.9874. And that does match that. Okay. Sometimes they might be a little bit off, but I think most of the time they'll be the same. And then I just, would specify and just specify on the test, or maybe maybe on some of them I can give you the option to use either the calculator or the table, but I usually want to demonstrate both, you know, maybe after I demonstrate the table on one and then calc on the other, then on another one I could like give you a choice, like you choose which one you want to use. But I'm going to demonstrate both of them here. And then I'll have to check that out on the test when I look at that, just to make sure before I publish that, double check that aspect of the test. And then I think this bottom part, yeah, I actually think that the bottom part I could have actually used that space for the bottom part is now what I'm thinking about. It says X scores, but now I'm not going to use the X score. I think what I could have done instead of squeezing that is because I think I have a D and E, but yeah, I think what I should have done now that I see that, I should have just said, like you're redoing C, complete the probability, and I shouldn't say using the X scores again, you know, I should just, because we transformed it already, so I should just stick, because we transformed, I should just stick with the Z scores, but including the calculator commands. Yeah, so I should have done this part in here. I should have said that you're using the table for this part. So let's see, shade the desired area, labeling the Z scores. Complete the probability using the Z scores. And include, okay, so I should have said using the Z scores and the table, the standard normal table. So in here, I should have said that we're using the standard normal table. And then let me white this out, sorry. Then all this stuff here, sorry, I should have just, well, you don't have to do white it out. You can leave it there, but I should have, I meant to say, like, I should have just put that for this part here. So we're using the Z scores. I'm not going to use the X because we already transformed them, and then use the TI-84 command. So then this part would have been the same. It started off as X's that were trapped between 17.1 and 38. And then we ran it through and standardized it. And we got these Z's. And then we used the two normal CDF, lower bound, upper bound, mu, and sigma. And then the lower bound was here, negative 2.26, and then the upper bound was 3.19, and then mu was 0, sigma's 1. And that was a second vars. That was a second vars, number 2. And then the lower bound was negative 2.26, upper bounds 3.1901. Tens, hundreds, thousands, 10,000s. Look at the rise of 5 or more. 9, 8, 7, 3, up to 7. Yep, so you're going to add 1 to that. Again, I will leave all the exact on your paper there on your tests. And then that does match that. That does match this. Yeah. And I'll have to look and see. I don't know on the test. Maybe I do ask for both on some of them. I'll have to look and see how I have that set up. But we did show you both in class all the time, right? In the videos, I always showed you the table and the calculator. So I don't think that you'd have to do the table calculator for each one because it's time consuming, but you do need to know both because I need to have you demonstrate both. So I'll say what I want the table to be used for and what the calculator, and then maybe on some give you an option to choose your option, but I'll have to look at that and see, okay? All right, let's see. Okay, let's see. To help students improve their reading, a school district decides to implement a reading program. It's to be administered to the bottom 7% of the students in the district based on scores on a reading achievement exam. Okay, so you see that bottom 7%? Okay, so I'm going to draw that up here, bottom. Let's do that here. See that right there? And I don't know what X is, but it's the bottom 7%. So I know that this area is 7%, which is 7 over 100, which is 0.07. So I do know that much then right here. The standard deviation is 18. Assume the variable is normally distributed. If the average score for students in the district is 122, average 122.6. So that's a keyword, right? That's a keyword, right? Average, that's your mu, okay? You know, standard deviation, that's your sigma, right? Okay. And then bottom, that's how you know it wasn't the top, it was the bottom, okay? Draw a normal curve and shade the desired area that represents the probability. Include the mean and standard deviation on the curve. Find the z value corresponding to the error using the standard normal probabilities table. Okay, so you're trying to find area is 0.07. So you're trying to find that on your curve. Okay, so let's see. So you're trying to find 0.07, and you know it's on the negative side because see it's on the, here's mu, it's on the negative side to the left. So you need to look up the table on the negative side. And besides, it couldn't be on the right side because see this starts with 0.5 and you see you need 0.07. So you need to go to the negative side and you need to look for 0.07. Probably 0.07, probably between these two, right? Point 0.07. Yeah, probably between these two, right? In here. So let's see where those are. Between this negative 0.07 and negative 0.08 then. Okay, so on your sheet, let's see. So it looks like it's negative 1.4. And then negative 0.07. And negative 0.08. And then the numbers are 0.0708 and 0.6. Was it 94? Okay, so you see here's the negative 1.4, and there's a 7, 8. If I increase this, see there's negative 0.0708 and 0.0694. Okay. Okay, so that's what I'm getting off the chart. So that's what I have. Okay, and this is where I said that if you have another basic calculator, that might be easier, because this is where you can have the scientific notation on this calculator. You can do the area minus the potential. Your area is 0.07, and you're going to subtract both of these potentials. So this one is 0.0708. This one is 0.0694. Okay. Okay, and it's easier if you do it on the basic calculator. 0.07 minus 0.0708 it's a negative, but when you take the absolute value of that, it's positive. And then 0.07, take away 0.0694. Is 0.0006. Okay. So if I do it on the graphing calculator, I think I get scientific notation on some of them. 0.07 minus 0.0708. See, that's scientific notation. So that one is -8 e to the -4, means -8 times 10 to the -4, which means you move it to the left, move it left 4 times. Okay, so, and this counts as one of the moves. So you need here 3 zeros and then the 8. And then when you take the absolute value of that, you still get the same thing we got here. But you have scientific notation. So it's a little bit easier if you do it on a basic calculator, because you don't have to do that. On this other one, 0.07, take away 0.0694. That one also gives you scientific notation. So that one gives you 6e to the -4, which is 6 times 10 to the -4, which is move it left 4 times. So you need 3 zeros and then the 6. And so see, that's what we got over here. Okay. So it just, I mean, if you don't have another basic calculator, then you just need to know how to move scientific notation. And then you want the one that's a smaller distance. So the ones place is the same, they're tied. Tenths, hundreds, thousands. Tenths, hundreds, thousands are the same. but it's not till you get to the fourth decimal that they're different. And this one is a 6, which is smaller. This one is an 8. So this one is smaller. 6 is smaller than 8. So this is, you want the smaller distance. This one has a smaller distance. So then you backtrack to this potential, then you backtrack to that, and then you backtrack to that. Okay, so that means you want the z value of this negative 1.4 plus this negative 0.08, which is negative 1.48. Yeah, so if you add that up, you add the negative 1.4 plus the negative 0.08, it's negative 1.48. So remember, if this is negative, these are negative. If this is positive, then these are positive. But this is negative, so this is negative. Okay. All right. Now, and it's because this is because we want the z value associated with the smaller distance. Now, I'm also going to remind you that if the values had fallen, if these values had been equal, then they would have said they would have values that fall halfway between the two z values. Then we actually want to take the average of them. Is actually what we want to do. If they're actually equal, we should take the average of them. Okay, so somewhere you want to make a note that you just want to make a little note to yourself that if the distances had been equal, then you would find your z by taking the average of both z values. So if these distances had been the same, like 0.0008, 0.0008, if they had been the same, then you would have added them both up and averaged them and divided by 2. Then you would have said that you had negative 1.47 plus negative 1.48, and then you would have added them up and divided by 2. So, and then you would have rounded that to the nearest hundredths because z values are rounded to the hundredths. So if the distances had been equal, then you would find z by taking the average of both z values. Okay, so that's what we're going to agree on. Because on your test, you might also have a problem that pops up where they are going to be equal, and then you want to know what to do when that happens. Okay. All right. Okay. Now the other thing I need to do also is to find your z using the calculator, because we also did that. To find the z using the calculator, we put that at the top. To find the z related to an area with the TI 84, you would have used this 3 inverse norm area mu and sigma. So we had z, right? That's what I did in class, right? Z equals. So inverse norm. So here, your area, this is assuming that the area is to the left of the curve. So it would have been 0.07. Mu is 0, sigma is 1. And that is a second vars as well. So second vars, and then number 3, and then area is 0.07, 0 and 1, and you get negative 1.47, and you have to round this to the nearest hundredth because it's a z, negative 1.4, and is that number 5 or more? Yep, it's a 5, so negative 1.48. And that's what we got. That's what we got using the table. Okay. All right. Let's see. Okay, now. Okay, now to find your x, because we need to find that score right on the test. Find the cutoff score. We're trying to find, this is the cutoff score. So that's where this comes in, x, and you need this z times sigma plus mu. So z, we just found it, negative 1.48. Sigma is 18, and mu is 122.6. So negative 1.48 times 18 plus 122.6 is 95.96. And usually scores are rounded to the nearest whole. Round to, does it say? Yeah, it says ones place. So nearest whole number. So that's ones place. So it's 5 here. Look at the number to the right. Is that 5 or more? Yep, that's a 9. So add 1 to that. So that's a 96. This bottom part. We actually didn't do this bottom part in class. They're using, I see here I have a reference to inverse norm. It's about the same, but we didn't do that in class. We just used this. So I'm not going to worry about that. Yeah. So I'm not going to worry. So they're showing this here where I use the inverse norm. And then I use the mu and the 18 instead of 0 and 1. But I'm not I'm not going to do that because this is not, that's not an, that's area to the left of the curve, but when mu is 0 and sigma is 1. So yeah, I don't feel comfortable showing that, doing that. We didn't do that in class. We just stopped here at this. So I'm going to actually omit this part here and just stop here. I'm going to go that route. Okay, let's see. And then I'll see if I have a chance to, if I have a chance, I will probably maybe look this up and maybe omit this and then put it back up without C. For those who haven't printed that yet, I'll probably do that. I'm gonna leave that out, okay? And that's not like on the test, I won't ask to do that because we didn't do that in class. In our videos, we didn't do that. So don't worry about that part, okay? Okay, let's see. And then this is the last part, central limit theorem. This is the last problem. What does the central limit theorem say about the shape of the distribution of sample means? Okay, so I have a note here. I guess this is in your ebook to see chapter 6, section 3, exercise problem number 5. And that might have been also in your online homework. But it says, this is important. It says that the central limit theorem says that the distribution will be approximately normal when the sample size is large, okay? So we have cell phone lifetimes. Assume that the sample is taken from a large population and the correction factor can be ignored. Then suppose in a recent study of the lifetime of cell phones found the average, that's a keyword, right? Average is 24.3 months. So that's your mu. So that's 24.3 months. The standard deviation, that's your sigma, is 2.6 months. And that's good, those are the same units, because if you had years and months, you would have to convert them to the smaller unit, like to auto months. So that's good, they're already the same units. A company provides its 45 employees with a cell phone. Okay, so that's good, it's over 30. If the number is under 30, it can still be done, assuming that it's approximately normal, approaching approximately normality. If it's less than 30, but this is good, it's over 30, it's 45. Find the probability using the central limit theorem, so that helps. So you need a new formula. See, you need a new formula, the central limit theorem formula, that the mean lifetime of these phones will be less than 23.4 months. Okay, so that's your keyword there. Okay, so less than, so see, here's 24.3, so it's got to be on this side because it's less than that. So it's somewhere on this side. And this is X bar sample means. And that's good. It's also in months. Assume the cell phone life is a normally distributed variable. Include formula and show work for the full credit. Draw a normal curve and shade the desired area, taking care to label the sample means, okay? And the mean, okay? On the curve, fill in the blanks, okay, like this here. For n and the standard deviation, okay? And then, okay, so, okay, and then here they have z way down here. So I'm gonna do the top here. I'm gonna start with probability. First, it will start off at x's. X means, and it was less than 23.4. And then we're gonna run it through the formula. Then we're gonna run it through the formula and put that z value in there. Okay, and we did that earlier. Let me go back and make sure I put the z value. Did I go back and put that value in there for z? Let me see. I think I did, yeah. Just going back to look because I'm just going back to check real quick that I put my, I did. I was making sure. Okay. All right. And then the important formula, it's x bar minus mu divided by sigma divided by square root of n. Remember, you have to kick this out. Okay. So be very careful with that formula. Okay. And then when we do this, this is one of the easier types because it's to the left. So if you use your table, you know, you're looking for this on your table. But if you're using the calculator, then you're doing this, right? The two normal CDF, lower bound, upper bound, mu, and sigma. Where your lower bound is the negative 10,000 or negative 1 E99, which uses the second and the comma. So you have a choice here, which one you want to use. So I think last time I did negative 10,000. So I think on this one, I'll do the negative 199. So I can show that because I think last time I did the negative 10,000. And then the upper bound, this would be, you read it from left to right. So this is your upper bound, which is 23.4. And then mu would be 0 and sigma would be 1. Oh, wait. I haven't transformed it. I can't use 23.4. I have to transform it. So yeah, I'm getting ahead of myself. I have to transform it. So this is the lower bound, but then the upper bound, I have to transform it. So I actually I'm gonna need another picture. When mu is 0 and sigma is 1. And then this is going to change to my z. So I do need another picture in there. Okay, I need another picture in that. Okay. Sigma's 1. Okay, so let's run it through the picture. Just go this way. Then I don't have any space. Let's go down this way. Okay, so X bar is 23.4 minus mu, which is 24.3. And then sigma is, what's sigma? 2.6 divided by square root of n is 45. And then push this out. Okay. All right. Okay. So let's see. Open parentheses, 23.4, take away 24.3, close parenthesis, divided by, open parenthesis, 2.6, divided by, and then you need a second, and then x squared, because on top of that you have your radical. So I can't remember if I hit second already. Second, and then x squared. There's your radical, 45. And then actually you need this arrow here. See how long that bar is? See that long? You need to push this arrow here. That's what this is for, to see, shorten it. And then you need to close your parentheses and then hit enter after that. And let's see. Okay, so I have negative 2.322070592. And then I'm gonna, that's a z, so around to there's hundreds. Is this 5 or more? No. So negative 2.32. Okay, so the corresponding area for z is equal to negative 2.32. And then I need to find the area. Okay, so on the table, I'm going to do, this is negative 2.3, and this is negative 0.02, right? So the first two digits, negative 2.3, and then that's 0.0, and then the 2, right? So when I look that up on my table, I'm on the negative 2.3. 2.3. 2.3 and then 2. So there's negative 2.3 and then 2. Can you see that right there? 0.0102. Can you see that? Negative 2.3 and then the 0.02. 0.0102. Zero, 1, 0, 2. Okay. All right. And then oh yeah, and then the z, now I can put that in. So first x bar 23.4, and in the new picture, see, my new z is, when I ran it through and transformed it, is negative 2.32. And then that's the area, 0.0102. Okay. Okay, now let me go just put this here. And I don't have to subtract or anything or 1 minus that because that was the simplest case to the left. Okay. Now on the calculator, lower bound, upper bound. So lower bound, yeah, so I should take this off here, right? Because we're not supposed to use this x. So I should take that off here, but put it here. Lower bound. So it's negative 10,000 or negative 1 E99. And if you're going to use that, it's the second comma. So I have that here. And then my z here is negative 2.32. Okay, so on a calculator, it's a second normal. So you got to do a second bars for that. Second bars for that. Second bars, and then number 2, and then lower bound. So I'm going to do the negative 1 E99, and it looks like I already did that. I thought I did the negative 10,000, but I don't. Okay, that's fine. So you hit the negative 1, and then the second, and then the comma, because the comma has the EE. And even though it says EE, it just shows up as E. And then 99. So it's a very small number. And then the upper bound is the transform, negative 2.32. You ran it through the formula. So don't put this in here. Like I almost, oh, don't put that in there because I didn't run it through. Run it through is 0 and 1. And then this is the area, so round to 4 decimal places because it's not a z, it's an area. 1, 2, 3, 4. If it's a z, you round to 2, but if it's an area, you round to 4. Is that 5 or more? Yes. So add 1 to that. So that gives you 0.0102. 0102. See, that does match. Yay. All right. Okie doke, class. Okay. All right. So good luck with your studying. Good luck with your studying. Okay. And then on your test, you'll have 110 minutes, 110 minutes to do that. Okay. To work on that. Okay. So good luck with that. All right. You're studying. Okay, take care.